Okay, so continuing on with section 6.1, definition. So the inverse, that's what we're defining. The inverse of a one-to-one, which means it passes the horizontal line test, of a one-to-one function f of x, denoted by f with a negative 1 of x, and this is read aloud. Pardon me. Read aloud, f inverse of x is that which undoes, undoes the operation of f of x. The operation of f of x. So, for example, if f of x adds a number to x, say 3, then that means that f inverse of x subtracts a number, that same number. It undoes whatever f of x does. Okay, so finding the inverse of a function. So finding the inverse of a function of a function. And remember, we can restrict most non-one-to-one functions to a part of their domain on which they are one-to-one. So step 1 is to let y be equal to f of x. Step 2 is to swap x and y. To swap x and y. Step 3 is to solve for y. And then finally, step 4 is to let f inverse of x be equal to y. So you might recall that the negative 1 exponent means 1 over, but this is not a variable. F of x is a function, so it's not the same meaning in this context. So for example, let's find f inverse of x for the following functions. Okay, so number 1, let's say we have that f of x is 2x minus 5. So do you agree that this function first multiplies x by 2 and then subtracts 5? So I bet that the inverse operation would then add 5 and divide by 2 to undo it. Well, let's see. So step 1. Step 1, we always let y be in place of f of x, because really, f of x is a fancy way of saying y. Step 2 is to swap x and y, so now we write x is equal to 2y minus 5. Step 3 is to solve for y. So we have x is equal to 2y minus 5. I can add 5 to both sides, so x plus 5 is equal to 2y, and then I can divide by 2. So x plus 5 all over 2 is equal to y. And the final step, let's call it pink, is to rewrite that y as f inverse of x. So I claim that f inverse of x is x plus 5, all divided by 2. Okay, so let's do another one, shall we? So subscript number 2. Let's say we have that f of x is equal to quantity x minus 2 cubed plus 1. So this function subtracts 2 from the input, cubes it, and then adds 1. So I bet we're going to subtract 1 from the input, take the cube root, and then add 2. But let's see. So what color I used. So number 1. we let y be in place of f of x, so x minus 2 quantity cubed plus 1. Step 2 in green, I swap x and y, so this becomes x is equal to quantity y minus 2 cubed plus 1. Step 3, I solve for y, so I have x is equal to y minus 2 quantity cubed plus 1, so let's subtract, so x minus 1 is equal to quantity y minus 2 cubed. Now let's take the cubed root of both sides, so the cubed root of x minus 1 will be equal to simply y minus 2. And let's add 2, so the cubed root of x minus 1, to which we're adding 2, will be equal to y. Finally, step 4. Actually, I probably could have, that's okay. I rewrite that y as f inverse of x. So f inverse of x is the cubed root of x minus 1, to which I'm then adding 2. Okay, so subscript number 3, let's do another one. So let's say we have that f of x is equal to the square root of x plus 7, from which we're subtracting 4. So do you agree that this function adds 7, takes the square root, and then subtracts 4? Well, I'll bet we'll first add 4, square it, and then subtract 7 to undo it. But let's see. So part 1, we let y be in place of f of x, so square root of x plus 7, from which we're subtracting 4. Step 2 is we swap x and y. So now this is x is equal to the square root of y plus 7, from which we're subtracting 4. Step 3 is to solve for y. So we have x is equal to the square root of y plus 7, from which we're subtracting 4. So I'm going to add 4 to both sides. So x plus 4 will be the square root of y plus 7. To undo the square root, I'll square both sides. So quantity x plus 4 squared will be y plus 7. And now I'll subtract 7 from both sides, so quantity x plus 4 squared minus 7 is equal to y. It's a terrible minus sign. Minus 7, okay. Last step is to rewrite that y as f inverse of x. So I claim that f inverse of x is quantity x plus 4 squared, from which I'm subtracting 7. Now, we showed above that a parabola, which this is not one-to-one, so I would have to restrict the domain. So note, must restrict the domain. Must restrict the domain.